Hello guys, welcome back to MedZone African Motifs, still on our power machines N6, and this is the steam plant that we are going to focus on from February 2022 exam, which was actually supposed to be those April examinations. So we're not going to waste much time. They were given actually a question where they tried to list the information for us. But here, let us consider what they are saying. The information, the following information is known about a steam boiler plant consisting of an evaporator and superheater. So that is what we are given there. It consists of an evaporator and a superheater. So I always talk about this, that it is important that you know what comprises of the boiler plant. It can have an economizer, an evaporator, followed by a superheater. But here we are just given evaporator to the superheater. These are the two things that you're given. And if we check on the information here, there is nothing that talks about the economizer. We do not have anything about the economizer, anything we do not have. So that means the only part that comprises of our boiler are two things. Like I said, it is best that you just have a sketch of how it looks like. In terms of the flow diagram, we're just going to have the boiler, all right, which is our evaporator to the what? To the superheater. All right. So these are the two things that we are having. All right. These are the only two things that we are having, an evaporator and a superheater. So it's very, very important you understand this. So meaning to say, according to our diagram, the stages will be the stage 1, stage 2, and stage 3. If it was having an economizer, it was going to be like this. An economizer here, an evaporator. I talked about this to the evaporator. So you're going to have stage 1, stage 2, stage 3, stage 4. That means we've got H1, H2, H3, H4. Here we've got H1, H2, H3. That is what we have. So you have to be very, very careful. Very, very careful. All right. So let us see what is happening here. They are saying we are given the thermal efficiency, which is, we've got the thermal efficiency in this case, which is fine. The heat value, which is whenever you're talking about the heat value, this is our calorific value, which is supposed to be in kilojoules, but this is megajoules. So to kilojoules is going to be 31 times 1,000, which is 31,000 kilojoules per watt per kilogram. I talked about this. Then they are saying the heat lost to dry combustion products. All right, remember, sometimes they do ask us to calculate this heat that is lost to the dry products in this case, all right? Let us just say dry products in this case. Sometimes they do ask us to calculate this. They do ask us to calculate this. All right, so this is given in megajoules. Again, if you multiply by 1,000, that will be 4,970. That will be kilojoules per watt per kilogram of the fuel. All right, per kilogram of the fuel. Then we've got the heat lost to wet combustion products. So this is Q wet. These are the products that you're talking about. Okay, let's just be, it's gonna be clear. 1,680 again if we multiply by 1,000. Okay, no problem. They're just saying, all right, then the chimney best temperature. We talked about this chimney in our other question papers that we had, and I said this, when I talk about this, that is where we are having the flue gases at that part. So when you're considering the chimney best temperature, that is the temperature that is going out. All right. So this is your T out. So this is your T out. There we are talking about what? The flue gases. So as long We are on the chimney. We are talking about the flue gases. All right. Then we've got the boiler room temperature at 29 degrees Celsius, which is going to be the Tn of the flue gases. So this is your Tn. Then the mass of combustibles in the fuel. Right. Remember, we've got the combustion products here. So we are given its mass. The mass of those combustible products. All right. That we have, which is given per kilogram fuel, which is fine. Then the specific heat capacity of the dry flue products. All this is part of what? Is part of the chimney and is part of the gases. So we also have CP for these dry products that I have, which is the flue. There's the part of the flue gases, which is the part of what? Of the chimney, like I said before. All right, then this is mg, just for these products. Then the chimney base pressure. Remember, the chimney, we've got given its base temperature. We are also given the pressure there at the chimney. This is the best temperature at the chimney. We've got a pressure. All right, take note where we are. Take note. Then the feed water temperature. Where is it entering? Entering the boiler, because here we have only the evaporator or the boiler to the superheater. So this feed water is the water that is entering at the entry of the boiler, 54 degrees Celsius at the entry. So this is T1, it's still water. Take note, this is still water. So when we are having water, it means our enthalpy, which is H1, is equal to HF, which is the enthalpy of what? Of water at 54 degrees Celsius. What is the enthalpy? What is our HF there? If we consider according to our temperatures, saturation temperature, if we consider that, which is supposed to be in degrees Celsius, we need HF, which is supposed to be in kilojoules per kilogram. So let us go to the temperature of 54 under HF. So this is 54 here. All right. Sorry, this is the 54, this one. Under the 54, as we are going straight. So you're going to need this one, which corresponds to the what? To the HF on top. So this is 226 kilojoules per kilogram. So this HF is 226 kilojoules per kilogram. I think I talked about this and how it is important for you to list this. All right. Then they are saying the steam pressure. The steam, definitely we are talking about what? At the evaporator boiler, which is from the superheater. The pressure at the end, which is our P3, is 1,500. This is 1,500 kilopascal. The same as the pressure here, it will be 1,500 kilopascal. Remember, I mentioned also about this condition. This condition, I mentioned about this. Then they are saying here, the steam temperature, which is the superheated temperature there, all right, which is the steam pressure. So that's T sup. We are given 350 degrees Celsius. All right. Then they are giving us, this is CP, the specific heat capacity for steam in the flue. Take note, this is for the steam in the flue. We are talking about the flue gases. Yes, it's for steam, which means there we're supposed to be talking about H sup, but it's H sup for what? For the flue gases, for the flue gases, not for water, not for steam. I mean, not for steam. That is the one that we are having there for what? This is for the flue in the flue. So this is not the specific heat capacity that we are used to, that which is the one that we use to find H sup for steam. This is not the one. This one, yes, it's H, but for the what? For the flue, gases. So this here is not the one that we use when we are calculating H soup for steam. So you must be careful there. You must be very, very careful. All right. So that is the information that we are given consisting of an evaporator. All right. Then the other thing that we need here. All right. I wanted us to check something about the steam. All right. The mass of steam, the heat, this and that. All right. All right. All right. We want to check also about this steam. We are just given its thermal efficiency heat value, the heat lost to the dry. All right. All right. This is what we are just given here. The temperature of combustible, then chimney base temperature, the feed water temperature. All right. Then the other thing that you are to consider here, if you are to consider on this part, we are not given, we are just given the feed water temperature. We are not given the temperature at the output here. We are not given the temperature at the output, like what this 54 that we have on this consideration. We are just given this one, the 54. We are not given at the output, of our evaporator. We are not given the output there at the evaporator. So about H2, we are not given that consideration to say this here is wet or it's dry for H2. So let's just leave it like that. All right. Then for this one, our H3 is going to be, remember this is for the superheated. So our H3 is H soup. So you are wondering now to say, how is it that here we are not given the specific heat capacity for the steam? Remember, I said this is for the steam, whereas this was the specific heat capacity for steam in the flue, This is not the specific heat capacity that we use here for water. This is the water, and remember, this is the water, this one. It is water, feed water entering. So its specific heat capacity, when it is now steam here, we do not have. But for the gases, we have for the flue gases. So meaning to say this one or this condition, they will give you values that you are going to find on the superheated steam, on the superheated table. If you check here, this is for the steam table, all right? This one is just a normal steam table when you're given pressure, this and that. All right, but if you move on, you're going to check something like this. You will see that there is a table that it will be written superheated on top. There it gives you the pressure. So these are the pressures that are going down, all right? And these are the temperatures, these are the superheated temperatures. These ones are the temperatures. So what we are simply taking there is the pressure. Remember, our pressure was 1,500. So we want 1,500 kilopascal. This is the pressure that we want at a temperature of what? At a temperature of 350, the one that we are given there. What is going to be H soup? If we check here, there's H soup, H soup, H soup. So meaning to say we are able to find H soup direct from there. So let's go to 1,500 at under pressure. Under pressure, this is somewhere here, 1,500, all right, kilopascal. Then the temperature of 350, this one, where do they meet? So we want where they meet under H soup here, where they meet under H soup. That is, they meet here, which is 3148. So this is our H soup at that consideration, all right? Which is we can have this direct from our what? Direct from our superheated steam table. So this here, we can find it direct. We got it at 3,148. These are kilojoules per what? Per kilogram. All right. So that is what we can fill in for our information so far. Like I said here, we are not told whether it's wet or it's dry. Whenever we need to use that, we are going to do a comparison. Let's see if we are going to need that part or not. Calculate the following quantities by making use of the steam tables only. 4.1, it was the specific enthalpy of 4.11, the feed water entering the boiler. Already we stated this from our steam table. We already have this, our H1, 226. This is for the feed water entering. So we got 226 kilojoules per watt per kilogram. Then the steam leaving the superheater, which is our H soup. So this is HF, then this is our H3, which you said is H soup there, of the steam leaving the superheater. Remember, we took this value from our superheated steam. So this was 3,148 kilojoules per watt per kilogram. We are just using our tables there. All right. Then 4.2, the mass of steam generated per kilogram of coal burnt. Whenever they ask you a question like this, I told you guys, what do they need is to find the mass of steam over the mass of fuel like this. This is per kilogram fuel burnt. So where and how are we going to have the mass of steam over the mass of fuel? We must use the information that we are given in order to find this. What am I trying to say? Remember, there are some values that, or there are some questions that they ask you. Like if you check here on our information, sometimes they can ask you to calculate the thermal efficiency. They can ask you to calculate the heat loss. They can ask you to calculate the heat loss to the waste combustion. Of all the information that they can ask you to calculate that you are given, is there anything that you can take as an advantage where the mass of steam and the mass of fuel is given? Yes, it's there. Where is it? On our thermal efficiency. Remember the formula for thermal efficiency. All right. We are given a thermal efficiency of 68.73. All right. Remember from our thermal efficiency formula, I say that the thermal efficiency is equivalent to the mass of steam into H last. This we are considering for when you are not given, like when they just write thermal efficiency. This is for the entire plant. I told you guys, when you're given like this, you use for the entire or for the whole plant. Unless they specify for you that the thermal efficiency affecting the boiler only, there you use it for the entire plant. And I said this is H last minus H first. All right, everything over the mass of fuel times the calorific value. So according to our plant, the last H enthalpy that we have is H3. So that's where you focus with what you're given on your diagram. There it's H3. What about our H first? Which means we're talking about what? H1. So this is our formula that we are supposed to have. We are simply saying the thermal efficiency is equivalent to the mass of steam into H3 minus H1. Meaning to say, if our last point was H4, you were going to use H4. But in this case, it ends at 0.3, so it's going to be H3. And I say this calorific value must be in kilojoules per watt per kilogram, since all these are in kilojoules per kilogram. So as we need this, the mass of steam over the mass of fuel, how can we make this the subject? Take note, we're simply going to take this to the other side. We multiply by it, then we divide by this one. All right. So we're going to multiply by this side. We divide by this. We are left with what exactly what we want. The mass of steam over the mass of fuel is going to be, like I said, this one and this one will cancel. So it's going to be the thermal efficiency times the calorific value over H3 minus H1, which is H last minus H first. So that's it. By substituting what we are given, we can be able to find the mass of steam over the mass of fuel. given our thermal efficiency, just writing it as a decimal. Remember our thermal efficiency, we are given, this was 68.73. So we are just substituting there 0.68 something as a decimal. So our thermal efficiency as a decimal, that's 0.6873 times the calorific value we are given from our table. Remember, I changed that value to kilojoules and it gave us 31,000. Guys, let us consider, take from your table. H3, we calculated also, or we stated H3 from our information. H3 is H soup, which is this, and H1, which is 226. We're just subtracting your values there. 3,148 minus 226. So this is going to give us the mass of steam over the mass of fuel. That is per kilogram of the fuel that was taken in. Per kilogram of what? Per kilogram of the fuel. So in each and every case that you are given, in each and every case, it is very, very important that you understand. So you're going to obtain something like 7,291,683. So just fix your calculator to 3 decimal places. It's going to be 7,292 in kilojoules per watt per kilogram fuel. All right. So this you can just fix your calculator. Let me just bring this so that because all the calculations that I'm going to have, I'm going to fix my calculator to 3 decimal places. So I'm just going to do it like this. On my calculator here, it's going to be shift set up. You go to the fix on number 6, then to 3 decimal places, it's 0 to 9. So I'm going to press 3. So my answers is going to be 3 decimal places. All of the answers that I'm going to get, 0.673 multiplied to 31,000, everything over 3,148 minus 226. So this is going to be 7.292 to 3 decimal places. So this is how all my answers are going to be. So make sure that you do the same so that we be on the same page. All right. So we have got the mass of steam over the mass of fuel. All right, we are going to need this. We are going to definitely, there are so many calculations that will need this. So I'm just going to write it down. The mass of steam over the mass of fuel, we got this as 7.292 kilograms per kilogram of the fuel that is being used. All right. So like I said, definitely we are going to need this information. We are going to need it. All right, let us move on to the other part of our question and see what were they saying here. What are they asking? All right, the 4.3 is the equivalent. So there is the equivalent evaporation from and at 100 degrees Celsius, and that is 3 marks for that. The equivalent evaporation. Also, we are not told there at which point. So we are using for the entire plant, just like our thermal efficiency. We are going to take this for the entire plant. So if we are taking this, our equivalent evaporation for the entire plant, then that means we're going to have our formula as equivalent evaporation. Remember, is the mass of steam into H last. So always this is H last minus H first over the mass of fuel times the, this is 2257. All right. So according to the entire plant, our last H is H3. So that will be H3, H first, which is H1. So that will be our formula. We're just inserting our values, so our equivalent evaporation. So this is the one that we calculated before, the mass of steam over the mass of fuel, this one, which is this value. So we're just going to write it as it is, which is 7.292 times what we are remaining with this. This is the part that is remaining. We are remaining with what? We are remaining with H3 minus H1, which is H3, which is our H soup. That's 3,148 minus H1, which is our H1, 226. Everything over what? 2257. So this is the mass of steam over the mass of fuel. This one, we already have that value. So we are just inserting as it is. So that was going to give us the equivalent evaporation, which was going to give us to 3 decimal, like I said, if you fix your calculator like that, it's going to be 9,441. So that is your equivalent evaporation. We might need this value again. Let us just write it aside, 9,441. All right, just leave it like that. We are done. Okay, let's check another question. So like I said, guys, it's very, very important that you note this one. Let me just remove this, guys. It's already disturbing us now. All right, it's because, guys, if I leave this information a bit too much, and you remember our board, it will end up dragging. So that's why I'm just removing this so that we just remain with a small space to work on. 4.4, the mass of moisture. So there we need the moisture there. In the flue per kilogram of coal. Okay, there we are talking about the flue gases, which is when it is wet. The flue gases, which is what? Wet. Which is the moist one. All right. So it follows that, I don't know if I explained this formula before, but if not, let me explain it. It follows that if we are to calculate Q for the moist, it is a Q that is for the moist. We are talking about the moist gases there, the flue gases, which is Q moist. It's going to be the mass of the moist air, the gases that are moist, all right, times H, which is for the moist. But how do we find this? All right, how do you find this M for the moist or flue gases? It must be wet, this one. So we remove the one that is when it is dry. Remember, this can be dry, and there is when it is wet. Okay, let's get back to our information. When it is wet and when it is dry, totally dry, the CP in the flue, the specific heat capacity of steam, meaning to say there it's totally dry. This is for the superheated. So you're going to have the difference there. All right, so that's going to be the mass of moist flue gases into H sup minus H wet. This is for the flue gases. This is for the flue. Take note, guys, there is the part that is consisting of the flue. So the H sup is affected since in the flue gases, we are given SP for the flue gases. And what about this H wet? This is the one that is operating at the room temperature. We are given there at the room temperature, if we take note here. The boiler room temperature, Tn, is 29 degrees Celsius. So if it is HW, if it is HW, which is for water, just like here, we had H1, which is HF for water. This was for water. So it means that is HF there. The HF at what? At the room temperature. At the room temperature. The boiler room temperature, which is at 29 degrees Celsius. What is our HF? What is our HF there? At 29 degrees Celsius. All right. So if we are to consider this on temperature at 29, our HF there, it corresponds to 121 kilojoules per kilogram. So that is our HF there. So this is 121 kilojoules per kilogram. Then H sup has to be calculated. This is not H sup, this one that we see here. Guys, this is why I said this question is, you have to be very careful because it was having a confusion to say, this one is not the one that, this is for the steam for water, when it is water that is entering the direct water. This is for the flue gases. This is for the flue gases. So we are going to calculate H sup. This is what we need. Do we have the mass here? Do we have the mass? We have to determine that. All right. In this case, we are not given this. All right. So this is the one that we need. Remember, that was our question here, the mass. So that means here we are going to find Q moist. Guys, how did I use this formula? Is because we want the mass of the moist air. All right, the mass of the moist in the flue. All right, so it's me, guys, who's now having a confusion. There's a lot of things here. You see, guys, your N6. So this is for the moist. So that is where we took this formula. And here we need them. This is the one that we need here. All right. So we are given this, remember, this one, we have it from our information. So like I was saying, in order for us to have this, we have to calculate our H soup. All right, so let us just have our calculation for H soup here. So this is H soup for the what? For the flue gases. Just because this is the steam of in the flue, the steam, guys, the moment you hear the steam in the flue gas, it means the formula is not going to change. HDCP, Hg into Cp, T soup minus Ts. But what is happening now is this is for the flue gases. So here we need Hg and Ts from the given pressure, which is the pressure now. Not this one, not this one, not this one, because this one is for the water which is entering this pressure. That's why I say forget about this diagram. We go back to our information about the flue gases here. We are told about their pressure. Here we have got the chimney base pressure is 100 kilopascal. At the chimney, that is where we have what? The flue. So we have the flue at the chimney. We've got the base temperature, which is 255. This 255 that we're seeing is just like what we have for the superheated steam, but this is for the flue. So this is T soup for the flue gases. This is the pressure that we need for the flue gases when they are being superheated. I hope you understand me here, guys, because this we are referring to something else. So this taken at what? We saw that the chimney pressure is given at 100 kilopascal. And the temperature there, which is T out for the what? For the chimney there, which is our T soup, is 255. So we have T soup for the what? For the flue gases, which is 155. Is it 155? 255 there, guys. 255 degrees Celsius. Remember that, this one. So what we need is to find H soup. So also we have got the Cp here. The Cp, remember we are given for the steam in the flue. This one. The Cp of the steam in the flue, which is 2.12. We are also given that. So we also have Cp for the flue, which is 2.12 kilojoules per kilogram Kelvin. So this is it, guys. So like I said, at this pressure, let us find Hg, and this we fill in our information. We find H soup for the flue gases. We need the pressure at 100. All right, this is ending at 70. So let's check the next one. All right, it seems like I did not insert this page, guys. It seems like I did not insert this, but if you are to check, because I'm having a hard copy here, so let me check on the hard copy. But guys, I know how. Now you know how to find this. You just go on pressure like this one. You go on pressure, then straight you need TS there, and you need Hg. Remember, we need TS and what? And Hg at a pressure of what? At a pressure of 100. So I want you to go under your formula, under your steam table. You will find that Hg at 100 kilopascal, Hg there is 2,676 plus Cp, which is For the flue gases, we're given as 2.12 into 2 T sub, which is 255 minus Ts. At that pressure of 100, you will find out that the temperature there is 99.6 degrees Celsius. All right, so it's unfortunate that I just did not insert this when I was preparing this class. So this is H sub for the what? For the flue gases, which is to 3 decimal places, going to be 3005.448 kilojoules per watt per kilogram. All right. So like I said, with this information, we can be able to determine or to find this Q in the moist. But here we need the mass. So meaning to say we have to ask ourselves here, because we are saying Q moist. All right, let me just remove this. We are saying Q for the moist flue gases in this case is equal to the mass of the moist, which is the one that we need. So are we given the units? Let us go back to the units. This mass is needed, is the mass per kilogram of the fuel, per kilogram of the fuel. So let us check what is our Q for the moist. What was the input? The heat lost to the waste combustion products. It's what? 1,600. I said it must be kilojoules per kilogram. So it's 1,600 and what? 680. So we have that one in kilojoules. So you can just insert that, and we find this one. So it's 1,680 is equal to we want the mass of what? Of the moist flue gases. Our H sub. This is our H sub for the flue gases. Not H sub, that one that we had when water is entering our boiler. No, this is for the flue. So it's 3,005,448, or you can just make it the subject before you substitute. Then H water, which is HF, it's 121, like I said, at the best temperature. So this, if you divide this bracket, this side, you are going to obtain the mass of the moist there, which is going to give us 0.5 82. Yeah, 3 decimal places is going to be 82. That will be kilograms per kilogram fuel. Remember, this is needed per kilogram what? Per kilogram fuel. Per kilogram fuel. All right, so it's going to depend. Maybe we might need this. So let us just write it down aside. So this is the mass of what? Of moist, which is the flue, for the flue in this case, which is 0.582 kilograms per kilogram fuel. So we might need this. If we need this, then we're going to use it. So this is how they just want you to play around with the information. Not all questions that you have that will be direct. No, you won't have something like that. You won't have something like that. So you have to be very, very careful. They want you to use information that you're given before. It is the same as this one again. This time they want us to find the mass of the dry flue gases per kilogram. Why? Because we have the Q for the what? The heat lost to dry combustion product. This is Q that is lost to the dry combustible product. So we can also do the same thing, but how do we find this Q for the dry products? I think this is the one that I mentioned before. This one that we just did for the wet, it was my first time, but this one I mentioned it before, that Q for the dry product is equivalent to the mass of the dry products times the specific heat capacity for the dry products times the change in temperature for those dry products. So G, I'm just going to use it for dry air. But the question is, we do not have this. And I mentioned also on calculating this, all right, that we can be able to calculate this. So in this case, because we do not have anything, we do not have, are we given this? We are not given the air fuel ratio, like what they do. The air fuel ratio is not given. If that was there, we're going to use the air fuel ratio, but it's not there. Because the air fuel ratio is not there, because remember that they used to give us air fuel ratio. This time they never gave us. is because they know that there is a heat to be used there, the heat that was lost to dry combustion products, QG. So from this, we can make this the subject. This one, just gonna divide. So it means our mg is gonna be QG for the dry, the specific heat capacity for the dry times the change in temperature for the dry. And here, everything is there. Don't we have this? We have got everything, guys. So Q for the dry, there we saw that it was 2 kilojoules. It was 4,970 kilojoules per kilogram. Then the specific heat capacity, this is for the dry gases, not for the superheated steam in the flue. This one, we've got CP, specific heat for the dry gases, CP gases, which is dry, 1.005. So there we are given 1,005 times the change in temperature. So it's going to be T out minus T in. So you're talking about T out, T in at the chimney here. T out 255 minus 29. All right, so that is 255 minus 29. So that is minus 29 degrees. So remember, we're talking about the gases. So the temperatures are not being affected. All right, we still have the same temperature, whether it's wet or it's dry. The same temperatures that we had before, these are the ones that we use. So this is the mass of the dry gases, which is going to be 21,882 kilograms per watt per kilogram fuel. All right. So like I said, okay, let me just write our mg. So now I'm going to talk. Like I said here, they did not give us the air fuel ratio. Sometimes they do give us the air fuel ratio where we combine from our air fuel ratio to find one of the missing values. But in this case, we were not given. So maybe they might ask us to find the mass of air, meaning to say we utilize the mass of the dry and that other mass that we had for the what? For the wet. All right, let us check here. Then they are saying the mass of air required per kilogram. You see what I was trying to say there? They are giving us this now. We are supposed to have this. The mass of what? Of air. In the mass of air required. So where are we going to have the mass of air required per col? So we have to check according to our information, guys. All right. Which one is going to give us the mass of air from this part that we have? Where? All right. Let me take you back to our information. We want to consider where do we have the air? The part that has got the air. And also considering the two masses that we are given there. We've got the two masses that we have. So no air fuel ratio. All right, no problem. Let's try to combine our information because we are used to a condition where we take it from what? From the air fuel ratio. But in this case, we do not have. All right. What we have so far is the mass of the moist. Then we also have the mass of the dry. Okay. Then if we are to consider on the other hand, remember we considered from this mass of steam over mass of fuel per watt per kilogram. So meaning to say we can also take that as an advantage because here at the end, we are given the mass of the combustible in the fuel. The combustible in the fuel. Meaning to say we have got the mass of the combustible that's gonna affect in the fuel. The mass of the fuel, of the combustibles. All right. So we are going to consider to say, if we talk about this total mass, the mass that is entering, that is affecting this flue, because we've got two things there. The flue that is wet, which is moist, and the flue that is dry. Then we consider the air and the fuel. We also have the mass of air to the mass of fuel. So meaning to say, this here can give us the mass of what? Of the air. All right, guys, like I said, we are big. We are not to that formula that we are used to, where we simply take from the air fuel ratio. No. So if we take this mass of fuel this side, it means the mass of moist plus the mass of the dry gases minus the mass of the flue, the mass of the fuel. It is going to give us the mass of what? Of air required. Everything there we have, and everything is in kilograms per fuel given. So that means our mass of air was going to be mm for the moist, which is 0.582, plus for the dry gases, for the dry flue, which is 21.882, minus for the fuel, which I mentioned before, which is 0.93. So you're going to subtract 0.93 there. So that is what we are going to have at the end. And that is what, let us just see here. So we have to be, we have to consider our formulas actually there, which are important, and manipulate to the favor of what you're supposed to have. Okay, just going to subtract this 0.93. So that's 21,534. So this is 21,534 kilograms per kilogram fuel. All right. So if we are to need this value, just hopefully we'll remember this. Let us just write aside. So we have got the mass of air there, 21,534 kilograms per kilogram fuel. All right. So that is how we could have attempted this question. Okay, let's check 4.7, another part, and see how we could have answered that last question. So again, here they're saying the heat transferred by the products of combustion to radiation, the ones that are transferred by the products to radiation. So it means in this case, we can also work with our heat balance, or we can just consider all the heat that is affecting all the heat that we have in this case. All the heat that we have. Or we can consider the heat balance. All right, so I'm gonna come back with this question, having the heat balance heat. All right, but I want us to consider this formula and explain it here, because it's enough an advantage that, you see, if we bring up formulas here and there that are important, let us try by all means to apply them. So if we consider, remember, we have the wet, which is the moist products here. We have the dry, all right? Then we also have the calorific value, which is the total. So the calorific value is our total. Then from that, we're going to have the part that is lost, or the remainder that we're going to have from the calorific value, all right, which is affected by the efficiency. All right, remember, we've got the thermal efficiency there. We talked about the thermal efficiency. So meaning to say, the percentage of that must be subtracted from the calorific value of the thermal efficiency. Our thermal efficiency is what? 68%, 68.73. So you must remove a percentage of that. So meaning to say, our remainder, which is the one that we're going to take to the radiation. Just going to write this as H, or you're going to write as Q, if you understand that way, Q radiation. So it's going to be, like I said, the calorific value minus the percentage that is from our thermal efficiency. So it's percentage times the calorific value of the thermal efficiency. Then we subtract all the other heat that can be taken. Which heat are we talking about? We've got the one for the dry. We also have the one for the wet. So that is the radiation, which is the remainder. So guys, because of this, if I try to have more than this time, I think it's going to affect my video. So what I'm going to do is to have this with a heat balance in our next class so that you can be able to understand me. Again, from the heat balance, I said you are supposed to be given the units. So since we are not given the units, let's maintain how the other are being given. They were given the other heat calorific value, this and that. They were given in kilojoules per what? Per kilogram. So meaning to say, we're going to use that consideration. Our calorific value, I mentioned that before, it was 31,000. We changed that to 31,000 minus the percentage of thermal efficiency there as a decimal, that's 0.6873. Remember, we talked about this also, times 31,000 minus Q for the dry. We are given from our table. All right, let's check. Let's hope it's not going to affect my class, guys. This one for the dry and also for the wet. So Q for the dry and Q for the wet, 4,000. This and that one in kilojoules per kilogram. You use the one that we converted to kilojoules per kilogram. All right, so let's just hope we are going to win here. So that was 4,970 minus 1,680. So that's Q. Lost to the radiation is going to be 3,043.7, which is kilojoules per what? Per kilogram fuel. Per kilogram fuel. Okay, so guys, let us take this for now. I just hope you understand me. Like I said, I'm going to come back with the different formulas that we need. Power machines is all about the formulas. It's all about the formulas. And you have to manipulate the formula in favor of what you are given there. So we shall have other typical questions. So also make sure that you join the membership so that you've got unlimited access to our classes, talking about introductions of topics, textbooks that you are using there. We can also be able to take 1 or 2 questions from there that we can have as a revision question papers. So make sure that you become a member by joining N5 to N6 studies so that you join unlimited learning platform from Maison African Motives till we meet again.